Hello there, this is Professor Shannon Gracie back again on our last section of 2.7, which is solving linear inequalities. When you're done with your homework, you ought to be able to do all this great stuff, graph solutions of an inequality on a number line, use interval notation, understand properties used to solve linear inequalities, solve linear inequalities, identify inequalities with no solution, or, sorry about the typo, or infinitely many solutions, and then solve problems using linear inequalities. So why don't you go ahead and get all warmed up. Get your math jumping jacks on. Pause the movie and work this problem. Ready, set, go. Okay, let's see how you did. Recall the volume of a sphere is equal to 4/3 times pi r cubed. Now, what do we have to do here? We have to find r, don't we? Because we've been given diameter of 11 meters. So remember that diameter is equal to 11, and the diameter is also equal to 2 times r. So that means 2r must equal 11, and r would therefore be 11/2 when we multiply both sides by a half. So this divides out completely, and we've got it left over on the other one. So that gives us the volume will be 4/3 pi times 11/2 cubed. So this will be volume is equal to 4/3 pi times, now 11 times 11 I know is 121, times 11 more, we would get oops, getting a little crazy here. We would have a 0 here, and then we would have a 1, 2, 1. So 1, 3, 3, 1. So this is going to give us a result of 1,331 over 8 once we cube the 11/2. And 4 divides out part of that 8. And 3 does not divide 1,331, so the volume would be 1,331 pi over 6, and that would be meters cubed. Okay, how'd you guys do on that one? Good. Alrighty, so now next part, vocabulary. Linear inequality in one variable. An inequality in the form ax plus b less than c, ax plus b less than or equal to c. So the line underneath the inequality means or equal to, ax plus c greater, ax plus b greater than c, or ax plus b greater than or equal to c is a linear inequality in one variable, right? This means less than. This symbol means, and this is if you're reading from left to right, means less than or equal to. This symbol means greater than. And this symbol means greater than or equal to. Okay. When we're solving an inequality, so the process of finding the now set of solutions, actually numbers, we don't want that, numbers, that will make the inequality a true statement. These numbers are called the solutions of the inequality, and we say they satisfy the inequality. The set of all solutions is called the solution set of the inequality. Now, graphs of inequalities. There are infinitely many solutions to the inequality x is greater than 5. In other words, the solution set for this inequality is all real numbers which are greater than 5. Can we list all these numbers? What do you think? What works? I mean, does 6 work? Yeah, 6 is greater than 5, right? What about 5.00001? You got it. That's also greater than 5. So do you see there's going to be infinitely many numbers. We don't want to list them. So let's figure out, what does a graph of the solution set look like? Well, and actually, you know, I'm going to go ahead. I'm going to copy this number line here so we don't need to keep spending our time redrawing. Isn't technology wonderful? So here, if we were to graph this, we would not want to include 5, but wouldn't we want everything right next to 5? So if we're shading all these numbers, right, how do we not include 5? Well, we used to do an open circle, right? But the new mathese for open circle is a parenthesis. Now you want the parenthesis to make sense. Like, for example, whoops. Do you guys see that this way it wouldn't make sense, right? Because you're not dealing with anything to the left. So we're going to go ahead, and the parenthesis kind of hugs the graph. Okay. So this here, if I wanted to put in my interval notation, solution, I would say 5, which is my left endpoint, and I'd be going infinitely to the right. There's no end there. So that in math, we just say infinity. Positive infinity means either infinitely right or infinitely up. And in this case, the movement is left or right, so it's going infinitely to the right. Now, if we put a parenthesis here, it means we are not including 5. So that is the result for interval notation of all numbers greater than 5. Now, set builder notation. You build a set, and we've talked a little bit about this. So you use the set notation. You describe what variable, so we had an x, and then the line means such that. Now, usually we would say x belongs to the real numbers, but your author just shortens it by saying x greater than 5. And the way that your author can do that is because, you know, the Blitzer has said that we're working with the real numbers. Okay? Okay. So graphs of solutions to Linear inequalities. Are shown on a number line by shading all points representing numbers that are solutions. Square brackets like this indicate endpoints that are solutions, and parentheses like above indicate endpoints that are not solutions. By the way, infinity and minus infinity are just directions, ideas. They're not actual numbers, so they're never included. You always use parentheses around plus or minus infinity. Okay, so let's graph the solutions of these inequalities. So why don't you go ahead and give this a try and see how you do. Okay, so x is less than or equal to 6. So all the numbers to the left of 6 are solutions, and you can always check them. Is 0 a solution? Well, 0 is indeed less than 6, so it's a solution. Now, once we get up to 6, we have to make a decision. Is 6 part of the solution? Well, is 6 greater than or equal to 6? Well, 6 is equal to 6, so it works. So we will put a square bracket here to show that 6 is included. So here are the different solutions. Interval notation, we have, what do I put on the left? Good, it's negative infinity this time because we're moving leftward, and we go to 6 and we put a square bracket around 6. And that was the interval notation. Set builder notation. Our variable is x, such that x is less than or equal to 6. Okay. So we're going just to tell you a little above and beyond the call of duty there. All right, so this next part, x must be greater than negative 3/2. So negative 3/2 is in the middle between negative 1 and negative 2. We're going to put a parenthesis because we're not including that endpoint. And then we keep shading and darkening the arrow. And again, we would have our interval, parenthesis, negative 3/2 to positive infinity, parenthesis, for the interval notation. The set builder notation will be, what's our variable? Good, it's x such that x is greater than negative 3/2. You have to learn both kinds of notation. Okay, let's put it all together. I mean, do you see these two that we've just done? This next one is saying that both of them, we want the solution set where both of them are true. So do you see that we're looking for the overlap, the intersection of these two? So if you look at them, we had said that x had to be greater than 3/2, and less than or equal to the 6, and then everything in between also works. And so this is the solution set here. And then interval notation for this one is just -3/2 with a parenthesis to 6 with a square bracket, and set builder notation is x such that x is between these two. X has to be greater than -3/2 and less than or equal to 6. Okay, good. All right, so this is what everything sort of looks like here. For x greater than a would not be included. It'd be the left endpoint, and we'd be going to infinity. If we're going set builder, we'd be saying x such that x is greater than a. And the graph would be looking like, if you had some a here, you would shade that, and you put a bracket here and shade the rest to the right. Okay, so why don't you try making the rest of these? Pause the movies and try making the rest of these and see how you do. Okay, let's see how you did. So next up, this one, we would now have the square bracket around a because it's included. And this would change just a little, x such that x is greater than or equal to a. And our shading will have a bracket around a and then shade off to the right. For x less than b, we're now, do you see, if we did the graph first, we'd be moving to the left of b, wouldn't we? And it's not including b because there's no or equal to, so we'd have a parenthesis. So let's go and make our deal here. Minus infinity to b, neither included, and this would be x such that x is less than b. Okay, x less than or equal to b. The left stays the same, but there's a square bracket around b. Over here, we would have x such that x is less than or equal to b. And this would be the same except for what? Good, except there's a square bracket around b now. Now let's see what this one would look like. X is just between a and b, but not equal to either one. So do you see we would have parentheses around them? And here's the beauty of the interval notation. Looks just like the graph, doesn't it, once you have that down? Over here with the set builder, you'd have x such that a is less than x, which is less than b. And then here, if you include both, you would have the square brackets around them. And this would change to a less than or equal to x, and x is less than or equal to b. And the graph we'll have the brackets, and everything in between. And then now A is not included, but B is included. So A would have a parenthesis, B would have a bracket, X such that A less than X less than or equal to B. And finally, now A is included and B is not included. So it would be A such that A is less than or equal to X and X is less than B. Now notice that the first four are tails of the graph, right? And the last four end up being line segments, don't they? So these last four are considered to be compound inequalities, and when you have it written as one single statement like that, then you typically have a segment of the line. All right. Parentheses are always used with minus infinity or positive infinity, which we just write as infinity. Okay. The addition property of inequality. If A is less than B, then A plus C is still less than B plus C. And if A is less than B, then A minus C is less than B minus C. The property in words. If the same quantity is added to or subtracted from both sides of an inequality, the resulting inequality is equivalent. So for example, if you have the inequality x plus 3 is less than 4, we can subtract the same number from both sides and get a result of x plus 3 minus 3 is less than 4 minus 3. And then, of course, you would end up with x plus 0 is less than 1, and x would be less than 1. You would have just solved the inequality. Okay, the positive multiplication property of inequality. If A is less than B and C is positive, then A times C is less than B times C. If A is less than B and C is positive, then A divided by C is less than B divided by C. Of course, C is not equal to 0. So in words, we have, if we multiply or divide both sides of an inequality, by a positive non-zero number, which is a little redundant. The resulting inequality is equivalent. So if we had 2 times x is greater than or equal to 6, we're allowed to divide both sides by the same number, and you see we would get x is greater than or equal to 3, and we would have solved the inequality. Now, here's the kicker, the negative property of inequality. Okay? So, if A is less than B and C is negative, then A times C is greater than B times C. If A is less than B and C is negative, then A divided by C is greater than B divided by C. So when it's negative, you have to pay for it. When you multiply or divide by a negative and you're dealing with an inequality, you need to pay for that by flipping the inequality. Okay? So C being negative means that you flip. C is negative, so you flip. Okay, in words, if we multiply or divide both sides of an inequality by the same negative number, and reverse the inequality. The resulting inequality is equivalent. Okay, so let's say we have negative x is less than 4. So what they're telling you, the rule is, if I divide both sides by -1, okay, I'll get an equivalent inequality if I reverse the symbol. Now, sometimes people don't understand why, so I'm going to show you why. So if we start out with what the original, negative x less than 4. Imagine adding x to both sides. Then you see we would get 0 is less than x plus 4. And then we could subtract 4 from both sides, and we would get -4 is less than x. So if you read that from right to left, do you see it says the big side is opening towards x, so it would say x is greater than -4? And do you see we got the same thing? So that is why it works. Okay, so here's some steps for solving a linear inequality. Simplify the algebraic expression on each side. So just like solving the equations, you simplify first. Use the addition property of inequality to collect all the variable terms on one side and all the constant terms on the other. Use the multiplication property of inequality to isolate the variable and solve. Change the direction of the inequality when multiplying or dividing both sides by a what kind of number? Good. A negative number. That's when you need to change, when you multiply or divide by a negative number. Express the solution set in interval or set builder notation and graph the solution set on a number line. So just kind of to give you a heads up, I ask for both on the test. The interval and the set builder notation, and I also ask you to graph. Okay? Okay, so let's look at these problems. So here's our inequality. You know, if we add 3 to both sides, do you see that we will get x plus 0 is less than or equal to 5, which gives us a result of x is less than or equal to 5. So that means x is moving to the left of 5. We shade our number line this way until right up till 5. Now what kind of ending am I going to put on this? Good, I'm going to be putting the square bracket because 5 is part of the solution set. So interval notation, minus infinity to 5, include 5, don't include the negative infinity. And then set builder notation, this was interval, set builder. Our variable is x such that x is less than or equal to 5. So believe it or not, all of this is what you would put your box around. Okay. Next up, we want to get the variables on one side, and so we also want to get this 8 out of there. And again, if you have trouble adding the same algebraic expression to both sides, then just do it one step at a time. So I'll get 3x's plus 0 is greater than 0x's minus 15, which gives me a result of 3x is greater than negative 15. And then I can divide both sides by 3, and I get x is greater than negative 5. Okay, so now I'm moving to the right of negative 5. What ending do I put on this one? All right, that's right, parenthesis, because we're not, negative 5 is not a solution, so we want to get right next to it, but we don't want to include it. Okay, so interval notation is, our left endpoint is negative 5, it's not included, and then we go to infinity, and set builder. My variable is x such that x is greater than negative 5. Awesome. Box all of this good stuff. Okay, part C. What do we have to do here with this 4? Good, we need to distribute the 4 before we can, continue on. So this 4 times quantity x plus 1 yielded this result. So that gives us 4x plus 4 is greater than or equal to 3x plus 6. If I subtract 3 x's, then I'm going to need to also subtract 4. So I'll bring it over here. I'll get x plus 0 is greater than or equal to 0 x's plus 2, which gives us x is greater than or equal to 2. Remember, 0 times x is 0. So our interval notation solution, 2 is our left endpoint. It is included, and we're going off to infinity. And our set builder is x such that x is greater than or equal to 2. And our graph, we want to go to the right of 2. And we're including it, so we have a square bracket. Awesome. How you guys doing? Pretty good so far? I bet you are. Doing great. Hang in there. Once that light bulb goes on, it'll stay on forever, I promise. Alright, so recognizing inequalities with no solution or infinitely many solutions. Okay. So, if you attempt to solve an inequality with no solution, or one that is true for every real number, you will eliminate the variable. An inequality with no solution results in a false statement, such as 2 is less than or equal to 1. The solution set is the null set or the empty set. So the empty set. And the graph is an unshaded number line. An inequality that is true for every real number results in a true statement, such as, 0 is less than or equal to 0. The solution set is minus infinity to infinity, or x, such that x is a real number and the graph is a fully shaded number line, because everything works. Okay, so let's take a look at this next one. Again, we need to use the distributive law here. So this is going to be 2 times x plus 2 times 1 minus 1 is less than or equal to 2x plus 1. This is the result of using the distributive law. So that'll be 2x, 2 minus 1, 2 times 1 is 2, decreased by 1 is going to give us plus 1. is less than or equal to 2x plus 1. Subtracting 2x, subtracting 1, we get 0x plus 0 is less than or equal to 0x plus 0. 0 is less than or equal to 0. Now, this works because of the or equal to, all right? Less than or equal to 0. So this is true, right? So we would fully shade our number line like this. Fun times, right? And then the interval notation would be minus infinity to infinity, and the set builder would be x such that x is a real number. Okay, last page. Woohoo! Let's do B. And actually, let's see. If you don't mind, I would like to change this one. I'd like to change this inequality, so I'm changing the problem. Okay? I'm changing the problem to 5x is less than 2 times the quantity x minus 7 plus 3 x's. Okay? So then we would get 5x is less than, I have to distribute the 2 throughout those parentheses. So this here is the results of the distribution. So we would get 5x is less than 2x minus 14 plus 3x. 5x is less than 5x minus 14. Now if I subtract 5x from both sides, I will get a result of 0x is less than 0x minus 14. 0 is less than 0 minus 14. 0 is less than negative 14. Is that true? Nope. This is false, right? So for this one, I suppose for the interval, there's no real interval of numbers. So why don't we just put the empty set, and for the set builder, we'll do the empty set with the empty roster brackets. And we don't shade anything. It's a completely unshaded number line. So that's the easiest graph you ever did, right? Okay. So here we go. Application. On 3 examinations, you have grades of 88, 78, and 86. There is still a final exam which counts as 1 grade. In order to get an A, your average must be at least 90. Okay? If you get 100 on the final, compute your average and determine if an A in the course is possible. So at least 90 means you must have greater than or equal to a 90. Okay? And what we're doing is we're figuring out if the exam grades, right, 88 plus 78 plus 86 plus the 100 on the final, equally weighted, so we get the average by dividing by 4, is that greater than or equal to 90? Well, when I computed the fraction up top, I got an 88. Is 88 greater than or equal to 90? No. So an A is not possible. Okay, so now to earn a B in the course, you must have a final average of at least 80. What must you get on the final to earn a B in the course? So for this one, we'll let X be the score on the final. Okay, so we would again have our 88 plus 78 plus 86, and then plus X, all divided by 4, and that's got to be greater than or equal to 80. So here, if we multiply both sides of the inequality by positive 4, this divides out and we will get 252 plus X is greater than or equal to 320. So subtracting 252 from both sides, we will get a result of 0 plus X is greater than or equal to 68. X is greater than or equal to 68. So you must earn at least a 68 on the final to earn a B in the course. And we're all done, guys. That is the end of chapter 2. Have a fabulous, fabulous day.